Now we will move on to the next part of our chapter, that is volume of an object. Now what is volume? Volume of an object is the measure of space it occupies. Space here means three-dimensional space. So here, the amount of space the object occupies, that is, the amount of height and length and breadth, the area and the height it takes. This complete space that the object occupies, it's called its volume. The capacity of an object is the volume of substance its interior can accommodate. For example, if you have a 1 liter water bottle, you know that the volume of water the bottle can accommodate, can have, is only 1 liter. And so the capacity of the water bottle is also 1 liter. Since the capacity of an object is the volume of substance its interior can accommodate. And since both are equal capacity and volume, so unit of measurement of both is also same, and that is cubic units. Cube here means raised to the power 3. So if our unit is, for example, let us say x is our unit, then cubic unit means x cube. But here we already know that volume would be in units of length. So if our length unit is meter, then our unit of measurement would be meter cube. Now volume of cuboid. Now if you keep on stacking, we know that a cuboid is formed by stacking up of rectangles, right? So if we keep on stacking the rectangles like this, and let us assume that the height to which the rectangles are stacked is h, then the volume is given by area that the rectangle takes, and we are taking it to be a. So our area is a. We'll multiply it by the height to which the rectangles are stacked, h. So our volume is given by area into height. And now to find the exact volume by using using length and breadth, we know that the area of a cuboid is given as length into breadth. So we'll just open it, length into breadth into height. So this is the volume of a cuboid, and this is how we find it. Where where L is the length, B is the breadth, and H is the height of the cuboid. Now, volume of a cube, you know that cube is also a cuboid, but it's just a special cuboid. A special cuboid, in what sense? In the sense that L is equals to B is equals to H, that is length, breadth, and height are equal, and we can say them to be A. So volume of cuboid will be, would be L into B into H, and volume of cube would be A into A, which is A cube, right? So this is how we do it, H into H into H, and we get A cube. And where A is the edge of the cube. This is our edge, right? This is the edge. You know now that these things are called edge. Now let us do the example to help you understand how to use these formulas. So we have a cube that has edge of 12 centimeter. We have to find its volume. It's a simple question. We know that edge is equals to 12 centimeter. Then its volume would be A into A into A, edge into edge into edge, or we can write it as A cube. So we'll write 12 cube, and 12 cube you might want to take calculator, or you can just calculate it by hand. So I'll just write down the answer that 12 cube is equals to 1728. And now the unit would be centimeter cube. So this is how we find out the volume of a cube. Now moving on to our next example, example number 11. In this it's given that a wall of length 10 meter was to be built across an open ground. So our wall is like this. This is our wall. You know the wall is always cuboid. Now it is to be made in a open ground, and the length is given to be as 10 meters. So I'll just write here 10. meter. And now the height of wall is 4 meter. This is to be 4 meter, and the thickness of wall is 24 centimeter. So this area would be 24 centimeter. Now if this wall is to be built up by bricks whose dimensions are given as 24, 12 and 8, then how many bricks would be required? Now to find the number of bricks, we'll simply divide the volume of wall. Let me write it over here. Number of bricks is equals to volume of wall upon volume of bricks, right? So let us first calculate the volume of wall and then we'll calculate the volume of bricks. But here there is a one inconsistency because we have meter, centimeter, centimeter. So either we convert add centimeter into meter or meter into centimeter. Now I'll convert meter into centimeter because then we'll avoid the decimal fractions, which may be a little difficult to handle. So let me just write the length of wall. This is our wall. Now length of wall is 10 meter, and as in centimeter it would be 10 into 100, so we'll get 1000 centimeter. Similarly, breadth is equals to, our breadth is 24 centimeter, our thickness is 24, right? So that would be our breadth. So 24 centimeter, no need of conversion because it is already in centimeter. Now height is 4 meter, which will become 400 centimeter. Now to find the volume, we know what to do. We know it is L into B into H, and we'll simply multiply 1000 into breadth is 24 into height, which is 400. So when we'll multiply, we'll get the answer, but let us not multiply it because in the previous videos also I've told you that whenever there is such fraction coming, then no need to multiply it. It will just add on to your calculation because in the final answer you will just have to cut it out, and cutting that is common, taking common and cutting the fraction is much easier in this format because you already have factors. So now let me find out the volume of bricks. Volume of bricks is, we are given its dimensions. It is 24 into 12 into 8. Now I'll also leave it like this. Now volume of wall is 1000 into 24 into 400, and volume of bricks is coming out to be 12 into 8 into 24. Now we see that 24 and 24 is cut, and then when we take on the further calculation, we'll get our answer to be 4166.6, and we can take it approximately to be 4167 bricks. So approximately we'll need 4167 bricks to calculate or to make a wall of 10 meter of such a 10 meter, 4 meter and 24 centimeter dimensions. Now moving on to our next example, example number 12. Here it is given a child is playing with building blocks. So we have our building blocks and which are of cubes. Now our building blocks is in cubes shape. So cube has all the edges as equal. Now he or she has built a structure as shown in the figure. Now if the edge of each cube is 3 centimeter, find the volume of the structure built by the child. Now we have to find the volume of a structure built by the child. Now this is our structure and we can see that it is built up entirely of cubes. So if we'll find now the total volume of the structure wouldn't be equal to the number of cubes into into volume of a single cube, right? So it will be equal to total number of cubes and the volume of a single cubes. Okay, so now we'll find out the volume of single cube. Now volume of a single cube is given as a cube, and our a is 3 centimeter as it is given. So 3 centimeter cube, and we'll get our answer to be 27 centimeter cube. This is our volume of one cube. Now, how many cubes are used? Let us count it out. Now it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now we have number of cubes is equals to 15. So to get the final volume of structure, we'll simply multiply 15 with 27 centimeter cube and we'll get our answer as 405 centimeter cube, and this would be our answer. That is the volume of this structure. Now you have seen how to find out the cuboid, how to find out the volume of cuboid and cube, and how to do questions and apply it to find out the volume of different shapes, different that are not geometrical, like this. We have converted into different cubes and then found out the total volume of this irregular shape.